I'm Kartik, also known as Silent FPV, and today I'm one of the top 10 fastest FPV flyers in India. I have won competitions, broken records, and even flown machines that cost more than a superbike. But just 2 years ago, I knew nothing about FPV. I built a drone for Robotics World Championship, Technosia. I went to the arena and crashed. I didn't understand the engineering, I didn't understand the physics. I just had expensive parts with zero knowledge. So, how do you build a world-class or not a world-class FPV drone? Amazon पे जाओ, FPV drone लिखो and done. But काश इतना easy होता. So, in today's video, I'll be going over how to build an actual FPV drone which is right for you. Yes, you, with the right equipments and right setup. Because extra पे किसी को नहीं करना. I'm going to show you the engineering, the coding, the economics behind building a world-class FPV freestyle drone. And if you watch till the end, I'll show you number one mistake that cost beginners lakhs of rupees. A mistake that I almost made. But before you buy a single screw, you need to define your purpose. Just like building a gaming PC. You don't just buy random parts. So, is your purpose racing, cinematic shots, or freestyling? Because for each of them, the specification varies. Just like in racing, you need a super fast drone. But in cinematic, you need smooth and stable drone. But today, we are building a FPV freestyle drone and aiming for the value build. Sourcing in India is tricky. So I use Anubis RC. They are out there in India since 2014. Then DRK Store, Robu, FPV Guru, etc. And do remember to check out the prices on multiple sites, as you can save 20 to 30% just like this. So now let's get to the workbench. We are going to use PDB Mario frame, the skeleton of a drone. We are going to use the 5-inch version and analog one, as we are an analog flyer. So now let's assemble it. This is the top part of the frame. Here we have a battery pad installed over. So this must be at the top of the drone. This is the bottom plate. And this, the plate with the press nuts over it, this should be placed just above the bottom plate. These are the arms of the drone. So, how we interlock these arms is, we have a groove over here and similar over here. We have to make this drone in an X formation. So in order to get an X formation, we need to place the motor arms such that these get interlocked over them and form a perfect X while placed over the top of the drone. Something like this. So this is how the formation of your motor arm should look like. So out there in the frame packet, you might get these two M2 screws. So one would be bigger one and one would be smaller one. The smaller one would be placed in the center of this frame and the bigger one should be placed at the side of the arm so that these standoffs could be placed right above them. This is the longer one. Place it like this and like this. So this is how it should look like. We always use carbon fiber frames as these are light and durable. Now place these standoffs right at the side screws of the motor arm, like this. Now, after placing the motor screws, you need these standoffs, as these would be used as the spacer between the upper plate and the bottom plate of the frame, so that you could insert your capacitor just in the middle of this. Take this motor and place it again like this. As this is an X-type frame, this is how your frame should look like. Now, this press nut plate should be placed like this, and you need to screw down all the screws. One tip, before installing the press nut plate, try installing these standoffs. It will be easier for you in the later video. Now, take this press nut, place it like this. Try remembering these 6 of the screws should be in front and you need to place at the back. And take one of these standoffs, just screw it into it. Same for the other one. Install it like this and just install the standoffs. After you have done this, take M2 size Allen key and just tighten them up. Done. Now, just place this press nut plate right on top of these. Now, take these M2 screws, take these capacitor pieces, place them in mid of these arms. These will even act as a support for the arm so that in any wild crash, your arm doesn't collide mid-flight. Just place this back, take M2 Allen key and tighten these nuts up. Now, take these 4 of the standoffs and one by one insert them on the arm screws. Similarly, like you tighten up these standoffs, tighten up these as well. So now you are 80% done with this frame. Now we're gonna create the front canopy for the camera. Take these parts. Now what you need to see is there might be L and R written on both sides of these, over right on the corner nut R, similarly right here L. Now take this part and you're gonna see there's gonna be written R on this side as well as on this R. This marked side should be outside, something like this. They should perfectly align with the holes, like this. Now, before placing it, let's take this and this part together. I have already installed a standoff, but there might be a 5th standoff for you. Just insert this standoff right in the middle of this TPU part. Remember to take this marked side on the outside. Take this and just place it like this. So the cut should be aligned perfectly with the cut of this frame. Take the longer screw, insert it like this and just screw it up. Do similar on the other side as well. Take the mark side L towards the inside and place it like this. For our convenience, we will be installing the camera first. Take the camera and place it right in the middle of these two. Like this. So the gummy should be aligned perfectly with both of them. Now take this part marked with L on this side for left and similarly out here. Place it like this and tighten them up. And just like that, the first part is completed. Now, the frame is completed. Next, the muscles. The T-motor. These are the golden standard in the FPV world. But we would be using the budget series by T-motors. Those are Velox series. We would be using 1750 kV motors. These are pretty good with handling all sort of weight over the drone. If you're trying to add a GoPro or maybe a big DSLR, they'll do your work. I'm pretty sure with that. Even though these are the budget series, these are really reliable. If you want to choose other motors, you can go for Axis Flying. Even those are really good. We can even go for TCI Hobby, really good motors. Now we'll just mount these motors up. One beginner tip. If your screws aren't tight enough, use Loctite. Really helps out. Loctite not just tightens them up, even reduces the vibration out there in your drone. Less vibration means more stable drone. Do the similar thing with all 4 motors. Now, as we're done with the motors, we would be installing the stack screws so that all of our electronics like FC and the ESC together, as we know, is known as a stack, so that the stack could be placed on these 4 of the screws. To install that, you're gonna see 4 holes out here. Just insert it and make it go through right through the press nuts. And my favorite part about making the drone is making the drone. So now we are finally completed with the frame and the motors, the muscles of the drone. Now, this is where most people mess up. This is the ESC, Electronic Speed Controller. Out here we would be using the SpeedEB 55 amps ESC. It's really good. The filtering out is really nice. It handles all sort of power. Plus the motor spike, it handles really well. So now we need to solder it. On we go to the soldering part. So out here we're going to be soldering the FC with the ESC. Even though you guys might have got those connector to connect this with this directly, but I have burned this up. So I'm gonna solder the wires from here directly to the FC. I have set the temperature to 320 degrees Celsius. Beyond 300 degrees, if you put too much heat, the solder pads of the FC might get burned up, so FC might mess up. and going under the 300 degrees, it's gonna mess up it anyways because the solder is not gonna heat up to that degree of you want. So first we're gonna tint out the pads. Take some solder, heat up the pad and just apply a bit of solder. It's gonna create perfect bubs. If you guys do not know how to solder, I recommend do learn how to solder first. So this is how the tint should look like. So this is how the soldering should look like. These are the pads, clean solder with the silver bulges. Now in FPV, the major thing that people face is interference. The major cause of the interference is the soldering. If you're not good at soldering, it's gonna cause huge problem to you later. So try learning soldering first and then come out. Now one more thing which I'm gonna do is, I'm gonna solder the camera wire onto the FC. I know it's not recommended to do it first, but it's easier for me to do it like this way. So one more tip, if you are new into flying, try twisting the cables. The twisted cables produce less IMF, thus giving you less interference in your analog feed. As you're on analog, these tiny things matters a lot because all of them together is gonna pile up and destroy your feed. Yeah, this is the most tricky part, but since I've done this a lot of times, this is my muscle memory now. So now let's place the ESC and the FC onto the drone. For ESCs, you can, if you want better ESCs or golden standard, you can go with the Rush FPV or Team Motors ESC. We are using the Zero Drag FC as they are incubated in IIT Delhi, so I bought from out there. Now we're gonna solder the wires of motor onto the ESC. We're gonna solder these motor wires onto the ESCs, these pads. So we're gonna name by 1, 2, 3, these 3 pads and these 3 pads. So 3 motor wires onto this. Don't worry about the direction of the motors as these would be configured later by the Betaflight software. Right now, well, I guess we have done with the motors like for 15 each. We got like 6K and then the ESC is gonna cost you like 5K, 11K and then the frame for like 4 to 5K, like 16K. And the camera of course is for like 3K. So right now we have like 25K in my hand. Be careful. Now, we'll be tinting the pad for the ESC first. Trust me, this is a really good tip. Once you tint the pad and add some flux, right now I'm not having the liquid flux, but we're gonna use this flux paste as well. Just add some flux. It's gonna be easy for the soldering wire to reach the higher temps. Now we have the shiny solder. So let's tint this pad first. The solder should always be round and shiny so that there will be less interference on your analog feed. Now we would be soldering this capacitor on the ESC. Remember to check the polarization of your capacitor and of your ESCs. Now we are going to tint this wire up because it's easier for you to solder it later, plus it's going to give you that shiny silver bob. So we are pretty much done with it. Now what we're gonna do is we're gonna add a VTX onto our build. Out here I'm using Infinite AKK DVR VTX. It's a 1 watt VTX, really nice. For the FCs we're gonna be using Zero Drag FC WAP version. It is incubated in IIT Delhi and that's where I got it from. So let's just solder our VTX onto the FC and voila, pretty much we are done. So this is how the soldering should look like. The shiny bulges which you can see on the wires, that's the one we require. So this is how the soldering should look like. One thing I would like to share with you is, 2 years back when I went to Technosia, one thing India's best FPV flyer told me was that my soldering is trash. Like literally trash. He could see out the pinpoints out of the soldering, due to which I had such a bad analog feed. And I would like to tell you, don't miss this up. So if you miss this point of not soldering too good, like having pure silver bulges out, you're gonna get a lot of interference. And one more thing, twist the wires up. Because more the twist is, less the interference would be for your feet. All we need to do is, we need to plug the MMCX pin into the VTX and set this VTX up. Now we are pretty much done with the drone. We'll be just adding the tape onto the motor wire so that they don't come cut loose while flying. I know I have the motor arm 3D print. Where is it? Yeah, this one. So this is a 3D print which I could insert, but nah, I'm not that guy. Now, brief for the drone. Camera, Kartik FPV Rattle 2, FC, Zero Drag VAP, ESC, SpeedyB 55 amps, motor, T-Hobby 1750 kV Velox, VTX, AKK Infinite D via VTX. Now, we would be adding the ELRS onto our drone. ELRS is the, you can say, the guy who talks to the drone and the radio. This is a receiver and this is a transmitter. So, we would be adding this ELRS directly onto the punch-in board on the Zero Drag. Zero Drag have all plug-and-play facilities, so if you're not good with soldering, you can just plug and play. And that's it, we're all set to fly in skies. Now, let's end this build by adding this GoPro mount and then the top plate. Now, just end this build up by adding the top plate and we are done with it. So this is how your drone should look like. Finally, the build is complete. So finally it's done. The build is physically done, but don't add the propellers yet, because if you plug in the battery and the motors go crazy, it will go into the flying blender and fingers are important. So to avoid that, always use a smoke stopper or a multimeter to check if there's any shortage or you might have messed up some wiring. So here, most of the tutorials end, but a drone without software configuration is just a paperweight. So we would be setting this drone up on the software named as Betaflight. So here are the 3 things we would be setting up right now. 1. The UART port. 2nd. The motor's direction. And 3rd. The VTX. Yeah, of course, I didn't forget the accelerometer configuration as well as the ELRS configuration. So let's jump into it. Head to the Betaflight app. Now, out here you can select your device. If you can't find it, go to I can't find my USB device and select it. Now, just connect to it. As you can see, my drone is tilted upside down. So you just bring it to the table level. Click on Calibrate Accelerometer and it will take its value as 00. Just head up to ports. Remember, this is for USB. When you connect your USB to a laptop, this UART port will enable it so that you can communicate with your FC and your laptop. Now on UART 1, we have serial, so I have turned on the serial RX for UART 1, and on UART 3, I am having my VTX. That's why I have added TBS Smart Audio. Go to configuration. Here you can select your craft name and your pilot name. Go to receiver. This is how you connect to receiver. Turn your controller on, click on system button, go to express ELRS and then just head to the bind button. Then you're gonna see a C out there. So it means the telemetry is connected. Now, if you are not able to see this, just go to the home screen, click on the model. Once you are into the model, just scroll down until you see internal RF and external RF. Out here, I have the internal CRSF, which is for ELRS, and I don't have any external. So just turn this internal from off to CRSF and your Express LRS should be working. Now jump back. Now out here in mode, once you have set it, go to aux, auto, and then just flip your switch of your arm. Then you're gonna enable this arm. Same if you want for angle, go to different channel and enable the angle mode as well. Now important, flip after crash, also known as the turtle mode, in which once your drone turns upside down, you can't recover it from your on side, so you turn this switch on, it will automatically flip itself to the front side and you can fly it as usual. Now you just head to motors, you just connect your battery, head up to motor direction, click on this and click on individually. Then when you click on single motor, the single motor should spin, and you can just check out with the layout out here and check if it's normal or reversed. Once you're done with it, you just need to head to the OSD. On the OSD, you can set up what sort of information do you want to see on your screen while you're flying. On the video transmitter, as I've already set my AKK transmitter, but what you can do is either you can go to the product page of the VTX, or you can just go to this tab. Out here you can see all type of VTXs out there. The most common one is the SpeedyB out there, but if you are using like Smart Audio, which I am using, you can just go to Smart Audio 2.0 or 2.0.1 if your VTX supports it. Just download the USA one if you are in India or any other country near US. But if you are in EU, specifically if you are in Europe, only then select the Europe one. Then head over back and pretty much you are done. Remember I promised you number one mistake? People build this 50,000 rupees drone, take it out to field and crash it. Money gone. सबसे पहले simulator चलाना सीखो. Take a radio controller, buy a simulator and just play with it. I have spent months on simulator. Thus, I build a muscle memory for each and every move of the drone. And if you are good at it, teams even might sponsor it before you even own a real drone. Even though India और China की terms इतनी अच्छी नहीं चल रही हैं, but who knows? Try your luck. But building this wasn't just about parts, it was about understanding how a component works, not how to just plug it in. This is what separates a normal pilot from a pro.